let's look at this series for e to the x. Now, one thing we know about e to the x is if you take its derivative, you just get back e to the x. And if you take its integral, you just get back e to the x. Let's do one of those on this series and show that what we get is the original series. So if we take this, and let's take its derivative. All right, derivative of 1 is 0. Derivative of this next term would be just 1 over 1 factorial. The next one is going to be 2x over 2 factorial. Then 3x cubed, or 3x squared over 3 factorial. And then the next one, which isn't written out, but you'd have x to the 4th over 4 factorial. Its derivative is 4x cubed over 4 factorial. And these keep going. All right. Now, if you think about it, I want to do this, this x cubed term first. If you think about what this factorial is down here, 4 factorial is 4 times 3 times 2 times 1. So I could rewrite this term as 4x cubed over 4 times 3 times 2 times 1. I could cancel these, and what I'm left with here is x cubed over 3 factorial. So if you just look at the end result, the 4 cancels with this 4, and so the factorial number on the bottom goes down by 1. So I've got x cubed over 3 factorial. If I do the same thing on these others, the next term over is going to be x squared over 2 factorial. Then this one is just going to be x, and then 1. And they keep going. So the series that we get here for the derivative of e to the x, sure enough, is the same as the original series we had up here for e to the x. So this is the series that represents that function. If we look down here at sine and cosine, if we take the derivative of the sine series, we'll get the cosine series. And I think that's easy to see. If you take the derivative of this, I'm going to copy it. So this is sine. I'm going to take its derivative. Look at what we get. The first term gives you 1. The next one gives you 3x squared over 3 factorial. Let's just go ahead and write that as, we'll leave it. Then plus 5x to the 4 over 5 factorial minus 7x to the 6 over 7 factorial. And if we reduce our fractions again, we get 1 minus x squared over 2 factorial plus x to the 4th over 4 factorial minus x to the 6th over 6 factorial. And that's exactly what we have up here for cosine. So this is cosine. And if we wanted to, we could take the integral of sine and we'd get negative cosine, and we could take the derivative of cosine and that would give us negative sine. But I think doing one of those is enough to see that these series act exactly like the functions do.